hold on the countdown net. Launch control will abort the launch auto sequence and immediately proceed into launch abort. In T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count. Operators advise the launch director whether structural breakup or fire is imminent occurring per Dragon manual escape flight rules. For those operators in firing up 4, in the event of a fire alarm, key operators noted in 57.83 will remain at their post while the alarm is evaluated. In the event that personnel safety is threatened, evacuate to the south-facing emergency exit, which leads directly outside. Firing up 4 and MCCX will go into a sterile cockpit and lock down for the duration of the time the launch escape system is armed. Launch control at this time, you may proceed with arming the crew arm for movement.
Over that, arming crew arm for movement.
T-minus 45 minutes and counting. You've just heard the SpaceX launch director give the final execution instructions to the launch team.
Access arm retraction started.
We're ready for propellant load. That'll begin in about 10 minutes. Before that, we've got crew access arm to retract happening now, and then arming of the launch escape system. Everything continues to look good for an on-time launch of Falcon 9 with Axiom 1 mission.
Dragon SpaceX for tablets.
Go ahead, Arthur.
As we prepare to step into LES arming, I need you to verify that the elastic bands are over the corners of all of the iPads in the vehicle.
Roger, stand by. SpaceX Endeavor, Arthur, I can confirm that the elastic band on the cycles are around the tablets and also.
All right, copy that. Thank you, MLA. And for awareness, that last call came in pretty quiet, so if you could speak up on the upcoming calls, that'd be great. Thanks.
Okay.
Okay, we'll give you an update here. Inside of 43 minutes, crew access arm has retracted from the Dragon spacecraft. Next up, we've got launch escape system arming. And then at T-minus 45 minutes, or T-minus 35 minutes, we'll begin loading propellant onto the Falcon 9. So right now, Falcon 9s go, Dragons go. Weather looks good, and the range areas are also cleared for launch. So Kate, John, everything is looking good. Inside of 42 minutes, everything continues to go well. Waiting now for launch escape system arming.
Endeavor, SpaceX for launch escape system.
Go ahead, Arthur.
All right, MLA, at this time I can give you a go to step through section 7 of 4.100, close visors and arm the launch escape system.
That should work. SpaceX Endeavour, visors are closed. We are arming the launch escape system.
Dragon, SpaceX, launch escape system is verified armed.
Copy, SpaceX.
All right, there you heard it. The launch escape system is now armed. You can see there the crew in their seats with the visors down. Launch escape system, is the first of its kind escape system. It provides escape capability all the way to orbit. It's a really important function to have. Obviously, no intention of using it today, but that's what those call-outs were there back and forth that we just heard.
Right, and as you heard earlier too from Administrator Bill Nelson, the importance of low Earth orbit. So speaking of just how valuable low Earth orbit is, the crew of X-1 will be conducting a tremendous amount of science over the course of their 8 days on board the ISS. And not only does that include 25 Axiom managed studies, but it also includes the Axiom crew participating in efforts that extend far beyond this mission. Some of those we actually looked at earlier. One of these broader studies is a series of health monitoring tests before and after the flight. A few days ago, I was able to connect with Dr. Emmanuel Riqueza to talk about the ongoing research this crew will participate in on behalf of the Translation Research Institute for Space Health, also known as TRISH. Here's our conversation.
Dr. Riqueza, welcome. It is wonderful to get to talk to you. Please introduce yourself and tell us, what is TRISH?
Absolutely. My name is Emmanuel Riqueza, and I'm the Chief Medical Officer at the Translational Research Institute for Space Health. And I'm also faculty at Baylor College of Medicine in Houston, Texas. The Translational Research Institute for Space Health, or TRISH, we're partners to the Human Research Program at NASA. And one of our main goals is to find and fund new disruptive research that is high risk but potentially high reward, with the end goal of keep humans healthy both in space and on Earth. And we have been working with commercial spaceflight missions since last year, and Axiom 1 is our 4th commercial spaceflight mission.
That's really fascinating. Can you tell us a little bit more about your primary areas of focus or what you're studying on this mission?
Yeah, so TRISH focuses mainly on the high priority areas of human spaceflight research. And I would say the 3 highest priority areas are radiation, behavioral issues that come from being isolated and confined in space. And the third one is how your body changes while you're in a different gravity field, either a zero-G environment like in space, or during different gravity fields when you are in the moon or Mars.
Okay, interesting. So what kind of systems or hardware are you working with specifically to capture this data?
For this mission, the hardware that we're using is absolutely optimized to provide, number one, the highest quality data, while being still easy to use, easy to implement, and being the lowest burden to the astronauts. So to collect all of this data, for example, vision changes, we have been using a small device, is roughly the size of a shoebox that you can see here. I have this here with me. So this is basically like having an optometrist on a box. Basically, the only thing that you have to do is just grab it, put it on your eyes, look at an object that is roughly 6 feet away from you, and after a few seconds, you get a prescription of your glasses as right here. So as I was saying, if there's any changes on astronauts during these missions, we'll be able to see how that changes with this device. We're also looking, I was mentioning, at behavioral changes, how being in an isolated and confined environment has any behavioral aspects. And for this one, we have been using a small tablet like this one, also to test the sensory motor adaptation, the balance disorders, and the space motion sickness. We're using a device like this. And for each of the crew members, we have a set of hardware like this, and it fits. The 4 sets of hardware fits on a medium-sized suitcase. So it is really easy to move wherever it needs to go for launch and landing.
That's wonderful. So what are some of the intended outcomes or goals of the research you're doing?
Yeah, so some of the outcomes and one of the main applications, number one for spaceflight that we want to get from this research is that short duration missions like Axiom 1 are very, very relevant in the context of Artemis missions. When we go back to the moon, the first missions are going to be roughly the same duration as Axiom 1. So anything new that we learn from these missions is going to be absolutely valuable. Really, every new piece of data that we collect in spaceflight could potentially solve and be that last piece of the puzzle that we're looking to complete what we need to know.
Well, Dr. Riqueta, thank you so much for speaking with us today. We wish you the best of luck.
It is my pleasure. Thank you.
All right, we are about 30 minutes out from launch of the historic AX-1 mission. It has taken an enormous effort from an incredibly dedicated and hardworking team to get to this moment. And that team wanted to take an opportunity to wish the crew of AX-1 well and Godspeed.
Hey X1, we're so happy for you guys and just want to let you know we've got you here on the ground in mission control, so fly high and have some fun.
From all of us here at the Integrated Performance Team, we want to wish you luck on your pioneering mission to the ISS and hope to see you in a couple years when AX-H1 launches.
It is not only an immense honor to get to watch your monumental mission, but also to have been able to support you on your journey towards this day as well.
Hey guys, can't wait for this mission. We put a lot of hard work in. We're excited for you all to have a great time up there, and good luck.
Thank you for helping set an important precedence ahead of a very bright future.
Good luck, AX-1 crew. Let's conquer space.
Hasta pronto.
Woo! We want to send you all off with good wishes in this incredible journey. Godspeed.
It has been such an honor to watch and support you guys as you prepare for this moment. I'm so proud of each one of you for the dedication, the long hours, and the hard work you put into making this a meaningful mission.
Hello, Axiom astronauts. Thanks for stepping up to the plate for this amazing journey.
You guys have trained hard, you've waited a long time, and this is now happening. Safe travels on this historic mission for the first private astronauts to go to the ISS. It's happening. Wave to us from up above because we'll be thinking of you from down below.
We're the Axiom safety team. We just want you to know that we are really proud of you and we've got your back. We're wishing you a safe and successful mission, and we'll see you when you get back on the ground.
Hi guys, we're the Axiom Soft Goods team, and we just want to wish you a good mission and get back safely.
It's a real pleasure to be talking with you guys right now, and we're super excited for you. I'm here to cheer you on along with the entire Crew Systems team.
Yay.
Thanks for everything you're doing.
I wish you all the very best, the greatest of success, and the most fun and the most challenging, interesting thing in your life. Go big and enjoy your time on the ISS. We'll see you back on the ground.
Hey guys, I am so proud of the Axiom 1 crew. It's so fun to be a part of something bigger than you and to contribute. Most important thing to remember, guys, take some time to look out the window and appreciate where you are. It's space.
We're T-minus 31 minutes and 40 seconds, counting down to the first all-private astronaut mission to the International Space Station. A few minutes ago, Falcon 9 propellant loading began on time at T-minus 35 minutes. RP-1 fuel loading is underway on both the first and second stages. Liquid oxygen loading is underway on the first stage. Now we'll finish up fuel loading on the second stage at about T-minus 20 minutes. Doesn't take very long. And then we'll begin loading liquid oxygen on the second stage at about T-minus 16 and a half minutes. We'll continue propellant loading on Falcon 9 up until about T-minus 2 minutes. Now, speaking of propellants, the Dragon spacecraft was loaded with its propellants about a week and a half ago, just a few miles down the road from the launch site at what we call Dragonland. In order to fly, Dragon needs a fuel and an oxidizer.
Start of stage 1 cryohelium loading.
For the fuel, we use monomethylhydrazine, or MMH, and nitrogen tetroxide, or NTO, for oxidizer. Now together, these propellants feed the Draco engines that will maneuver Dragon on orbit, changing its attitude, raising its orbit to get to the space station. But that propellant also serves a second purpose, and that would be to use in the 8 Super Draco engines that would power the launch escape system in an escape scenario. But right now on pad 39A, nice view of Falcon 9 with Dragon there. You can see the crew axis arm has retracted away from the Dragon spacecraft. The 4-person crew is inside Dragon right now. The launch escape system is armed. Propellant is going into the Falcon 9. So since we are at this stage with the launch escape system armed, that means the 8 Super Draco engines inside the Crew Dragon are ready, if needed, to launch the capsule away from the Falcon 9 rocket in an instant, should there be any kind of emergency associated with the rocket or the pad. We have the ability to use a launch escape system right now if it was needed. A couple other status items. Weather, as you can see, looks good. Probability of violating the launch commit criteria is less than 10%. The only thing we're watching is wind gusts, but we believe, having seen the wind for the last several hours, everything continues to look good. That should not be an issue. Weather is also good in the Atlantic Ocean should we need to use a launch escape splashdown site for the Dragon capsule. We've also got upper altitude winds we've been checking out. Balloons have been released by the range here recently. We continue to look good for upper altitudes as Falcon 9 flies through the periods of maximum dynamic pressure. And finally, on the range, of course, we have cleared the danger areas, the hazard, the caution areas. Everybody's out of there except the 4-person crew up in the Dragon capsule, very top of the rocket you can see in the picture. So coming up, T-minus 28 minutes, 30 seconds, everything continuing to look good on Falcon 9 with Dragon for the Axiom 1 mission.
Let's take a moment now to get acquainted with the vehicles that you see there on your screen. That's a live view of Falcon 9 with Dragon, our spacecraft on top. Falcon 9 rocket is a rocket, Falcon 9 rocket with the Dragon spacecraft on top. Together stands about 215 feet, which is almost 30 feet taller than the Leaning Tower of Pisa in Italy, which is 183 feet. Falcon 9 is a reusable 2-stage liquid-fueled rocket, which means that it's kind of like 2 rockets in one, the first stage and the second stage.
Very cool. So talking a bit about that first stage. The first stage is the bottom 2/3 of the vehicle that you see there. Has that nice patina. It's been reused a little bit. It's covered in soot from a previous mission. That first stage is responsible for accelerating Falcon and Dragon through the Earth's atmosphere and into space. To do that, it has 9 Merlin engines at the bottom of that first stage. Prior to liftoff, the Falcon 9 first stage is loaded up with nearly 1 million pounds of fuel and liquid oxygen. And the Merlin engines on the first stage are optimized for sea level. These achieve 190,000 pounds of thrust during ascent and descent. The first stage accelerates the vehicle through the Earth's atmosphere into space and then separates the rest of the rocket at about 2.5 minutes into flight.
From there, the first stage will do what no other orbital-class rocket in the world can do. It'll make its way back to Earth and target a landing on our drone ship, a shortfall of gravitas, which you see there on your screen. The seas look great. The blue skies, I don't think it could be any more picture perfect.
No, it's like a desktop right there, I think.
Our drone ships are essentially autonomous, powered spaceports that allow our rocket to land over the ocean. For reference, our drone ships are equivalent to the size of a football field. So while it may have looked kind of small on your screen, they're actually pretty ginormous in real life.
It's got to be to hold a rocket, right? As mentioned previously, Falcon 9 is a 2-stage rocket. It's 2 rockets in one. Above the first stage is the second stage. Now, the second stage has a single Merlin vacuum, or MVAC, engine, which ignites after the first stage separates.
Cryohelium loading.
Now, the second stage is essentially a smaller version of the first stage, and whereas the first stage is designed to power the vehicle out of Earth's atmosphere and the forces of gravity, the second stage is specifically designed to operate in the vacuum of space. The second stage powers the Dragon spacecraft to its specific targeted drop-off point in orbit.
The Dragon spacecraft is capable of carrying up to 7 passengers to and from Earth orbit and beyond, but for today's mission, it is carrying 4 members of the Axiom 1 crew. It is the first private spacecraft to take humans to the space station and the only spacecraft currently flying that is capable of returning significant amounts of cargo to Earth. Like the Falcon 9 rocket, the Dragon spacecraft is also reusable. Today will be the 3rd flight to space for this Dragon spacecraft that the Axiom 1 crew is flying in today. The previous flights for this capsule supported were recently the Crew 2 mission, and before that, the Demo 2 mission, which was our first human spaceflight mission. Pretty incredible.
Yeah.
Now, as we await T0 in just under 25 minutes, the ground operations teams are doing a series of system checks to make sure both Dragon and Falcon 9 are ready for launch. Let's take a look at what the ascent portion of this mission will look like.
Right, so once we hit T-0, we will watch Falcon 9 and Dragon lift off from historic launch pad 39A and make their ascent. At about 50 seconds into flight, Falcon 9's engines will throttle down to help pass through the period of maximum dynamic pressure on the rocket, or what we typically refer to as max Q. It's worth noting that once we hit max Q, the vehicle will be going supersonic.
Once we're through the period of maximum dynamic pressure, we can throttle up our Merlin engines again. From there, at about 2.5 minutes into flight, we have a series of 3 events that happen in rapid succession. The first of which is MECO, or main engine cutoff. This is where all 9 Merlin engines shut off in preparation for stage separation, which, as the name suggests, that is where the first stage detaches from the second stage, with the first stage making its way back to Earth for landing as the second stage continues on its journey with the 3rd event.
Right, now SES-1, or Second Engine Start 1, is where the Merlin vacuum engine lights up and propels the second stage, along with our AX-1 crew, into orbit. As Stage 2 heads towards its targeted drop-off orbit, Stage 1 will execute 2 burns in order to make its way back to Earth. The first stage is the entry burn, where 3 of the Merlin 1D engines will reignite and then shut down. This helps to slow the stage down in preparation for entry back into Earth's atmosphere.
While the first stage is heading back to Earth, the second stage will cut off its singular Merlin engine that was ignited right after stage separation. Once this happens, we'll wait for confirmation of good orbital